Okay, so over here we have to look at the heating graph and the cooling graph. We must know how to draw and we must know how to label all of them. Okay, so your heating curve, heating graph, your temperature increase, you should know your graph is an upward graph. Okay, so what's going to happen here? Your solid is over here once it hits the melting point. For example, water melting point is 0 degrees Celsius. So over here melting occurs, alright, and then after beyond your melting point it turns into liquid over here, and then over here your liquid turns into gas. This is your boiling point at 100 degrees Celsius. Recall your pure substance melt and boil at fixed temperature, so the lines have to be horizontal and it has to be flat. Okay, and then beyond the boiling point it will turn into gas. So we must be able to identify the states over here. A and B is solid, C and D is liquid, E and F is gas, and then at the horizontal flat line we must identify the change in state that is happening. In this case the process is melting, and in this case your process is boiling, and then during the change in state there is actually two states over there, right? Melting we have solid and liquid, boiling we have liquid and gas. Okay, we must know this. Okay, next one, your cooling curve, you lose temperature, you lose heat, lose temperature, right? So the curve is a downward curve. Okay, so same thing if we start from gas, right? When we see the horizontal line here, there's a change in state, and here there's a change in state. Okay, so here change in state, it must be the gas condensed to liquid. Gas condensed to liquid is also at 100 degrees Celsius, for example, if it's water. So important point over here, my boiling point is equal to my condensation point if it is pure. Okay, and then my freezing, this one is at 0 degrees Celsius. My melting point is equal to my freezing point. Okay, boiling point equals to condensation point, this one will take place at 100 degrees. Melting point equals to freezing point, this one will take place at 0 degrees. Important to know that these 2 points are the same. These 2 points are the same temperature, and it is always a horizontal flat line. Okay, identify the change in state that is happening, condensation and freezing, and then write in the state symbols here. Before condensation, of course, you have gas, and then condensation, there's two states where my gas turns into liquid, so gas and liquid state. After condensation, everything is liquid, and then liquid will freeze to solid. When it's freezing, my liquid and solid will be here, and then after that, there will be solid. Okay, be able to label all the points and then all the temperatures. Next part, this part is again repetitive and reiterating of how do we describe a change in state using energy. Okay, so when my solid turn liquid turn gas, okay, what's happening? Solid turn liquid turn gas. My 0 degrees ice turn to 25 degrees, turn to 100 degrees. So this is increasing, right? I gain energy. Okay, I gain energy. So what happens when you heat it? The particles gain heat energy, and then they gain kinetic energy. When they gain kinetic energy, this is your moving energy, right? This energy is used to weaken the attractive force holding the particles according to their position. If I'm talking about melting from ice turn to liquid, right? So this energy gain is used to weaken the attractive force holding the particles in regular and vibrating about fixed position. And then there is no increase in temperature, right? Because all the energy that is being gained is used to weaken the attractive force. Beyond the melting point, right? They have overcome the force of attraction, right? So from 0 degrees, melting is happening. All the energy gain is used to weaken the attractive force. Once it hit 1 degree, that's beyond the melting point, right? Beyond the melting point, all this attractive force has been weakened. They have been overcome, right? They have overcome the attractive force, and then they will start to move further apart from vibrating fixed position to sliding in layers, and then leading to a change in state from solid to liquid. Okay, this is the standard answer we write when we describe a change in state using energy. Okay, standard answer that we write, change the red points according to which state we are describing or which process, whether we are describing melting, boiling, condensation, or freezing. On the converse side, this one is gas change to liquid, change to solid. So from 100 degrees Celsius, I change to 25 and then I change to 0. Okay, so you are losing temperature or losing energy. So particles will lose heat energy, they lose kinetic energy. All this energy that is lost is being strengthens the attractive force. So your attractive force becomes stronger and stronger, right? So all this energy is used to strengthen the attractive force that causes your particles to be sliding in layers. Okay, there is no decrease in temperature beyond the freezing point. So when I'm freezing it, right, they are sliding in layer and then there is no decrease in temperature. But beyond the freezing point, right, the forces of attraction are so strong, the particles will move closer together from sliding in layer to vibrate about fixed position. They change from liquid to solid. Okay, important idea over here, when you lose kinetic energy, right, you strengthen the attraction force. Okay, when you lose the kinetic energy, you're strengthening the attraction force.